This will be for the con exercise. Analyze vertical asymptotes of rational functions. So there are 5 main steps for this exercise. You want to factor the numerator and denominator individually. Okay, and then you want to cancel out any terms on the top and bottom. In order to find the zeros, you set the numerator equal to 0 and solve. And to find the vertical asymptotes, you set the denominator equal to 0 and solve. And then you want to plug in any value or number in between the zeros and the vertical asymptote to see what the plus or minus sign is. So that will determine if the graph goes to positive infinity or negative infinity. All right, describe the behavior of the function p around the vertical asymptote at x equals -2. So we want to see if the graph of p, you see this function is labeled p of x. We want to see if the graph approaches negative infinity or positive infinity, and do that from both the left side and the right side. The left side is going to be the negative side, and the right side is going to be the positive side. Or I should say the left is not necessarily negative, but it's to the less than side, and the right not necessarily positive, but it'll be from the greater than side. So you'll see what that means when we do the problem. All right, I just wrote here the vertical asymptote is at x equals -2. So we said the first step is to factor the numerator and denominator. The denominator is already factored. In the numerator, we want 2 numbers that multiply to -24 and add to -2. So if we do -6 times +4, that's -24. And when you add these, they will add to -2. All right. So the numerator is going to be factored into 2 binomials. And you start with x times x, because that's x squared. And you add on the -6 and the +4. And that is divided by x plus 2. All right, and we said for the zeros, you set the numerator equal to 0. Okay, there's nothing to cancel on the top and bottom. I'm going to set the numerator equal to 0. Anything times 0 equals 0. So if this equals 0, you do +6 on both sides and you get x equals 6. All right, because 6 minus 6 equals 0. And if you do x plus 4 equals 0, minus 4 on both sides, x equals -4. All right, so these are the zeros. And if you set this equal to 0, you get x equals -2, which we already had from the write-up in the problem, that is the vertical asymptote. Okay, and we said we're going to plug in numbers that are in between the zeros and the vertical asymptote. So on the number line, we have +6. Remember, the greater numbers are on the right. So we have +6. We have -2. And we have -4. All right, the smaller numbers are on the left. So what you want to do, this is a 0, and this is a 0, and this is an asymptote. You want to plug in numbers that are in between the zeros and the asymptotes. That's what we said in the notes. So right here, in between -4 and -2, I think the easiest number would be -3. All right, so I'm going to erase some of this here so I can plug in -3 in this rational function. All right, so we're plugging in -3, so basically p of -3, because it's the function p. If I put -3 in this binomial, -3 minus 6 is going to be negative. If I put -3 in this binomial, -3 plus 4 is positive. and negative 3 plus 2 is negative. Okay, negative times positive is negative, divided by a negative is positive. All right, so this right here is going to be positive in between the negative 4 and the negative 2. And now we're going to do the same thing again in between the negative 2 and the 6. What's an easy number between negative 2 and 6? Well, how about 0? That's pretty easy. So let's do P of 0. All right, if I put a 0 in here, 0 minus 6 is negative. If I put a 0 in here, 0 plus 4 is positive. And 0 plus 2 on the bottom is positive. Negative times positive is negative, divided by positive is negative. All right, so in between here, it's going to be negative. Okay, so the asymptote is at negative 2. And if you are approaching from the right-hand side, this is the right-hand side here, the graph is going to approach negative infinity. So this will be negative infinity. From the right. All right, because it's to the right of negative 2. And to the left of negative 2, it's positive. So that means the graph approaches infinity, positive infinity, or just infinity. And that is from the left. All right, because it is to the left of negative 2. All right, so positive from the left, negative from the right. Answer C, positive infinity from the left and negative infinity from the right. Okay, it looks like they used positive infinity. I thought they would just use it without the plus sign. Describe the behavior of the function q around its vertical asymptote at x equals 9. All right, so I'm just going to write in the top corner here, x equals 9. All right, then I'm going to erase this here. All right, factor the numerator and denominator. Let's see. Two numbers that multiply to negative 5 and add to negative 4. Well, I think that's going to be negative 5 times 1. That adds to negative 4. Okay, so in the numerator, x minus 5 and x plus 1. All right, of course, you start with x and x because that'll give you x squared when you multiply. On the bottom, for the 81, two numbers that multiply to 81 and add to negative 18. So that's going to be negative 9 times negative 9. So on the bottom, x minus 9 times x minus 9. Okay, so if you set the denominator equal to 0, you'll get x equals 9. So we already confirmed this is the vertical asymptote, but that was already given in the write-up. And if you set the numerator equal to 0, either one of these can be 0 because anything times 0 is 0. If x minus 5 equals 0, then x equals 5. Because 5 minus 5 is 0. If x plus 1 equals 0, x is negative 1. Because negative 1 plus 1 is 0. Now on your number line, we'll put an x equals 9 right here. All right, and this 0 is at x equals 5. And this 0 is at x equals negative 1. All right, so we said this was the vertical asymptote right here. And this was the 0. So we're really ignoring this section here because we said we were going to plug in numbers in between the vertical asymptotes and the zeros. So in this section, what's an easy number to plug in? Well, let's just say we'll do x equals 6. All right, so the function is called q, so I'll make it q of 6. All right, and let me erase. Well, I don't need to erase. If we take 6, plug it in here, 6 minus 5 is positive. 6 plus 1 is positive. So positive times positive. On the bottom, 6 minus 9 is negative. 6 minus 9 is negative, so it's negative times negative. So positive times positive is positive. Negative times negative is positive. And positive divided by positive is positive. So in this section here, it's positive. Now on the other side, there's no restriction because there's no 0 here. So anything greater than 9, I think a nice number would be x equals 10. Okay, you pick any number greater than 9 because we're plugging in points around the vertical asymptote. All right, so we're going to do q of 10. 10 minus 5 is positive. 10 plus 1 is positive. 10 minus 9 is positive. 10 minus 9 is positive. So it's all positives. So this section here is also positive. All right. And so from the right, here's your vertical asymptote right here. So from the right-hand side, you're going to get positive infinity. Okay, this positive means it's going to go to positive infinity. From the right. And this plus sign here, same thing. It's going to go to positive infinity. From the left. All right, so we got positive infinity from the left, and we got positive infinity from the right. All right, because these are both positive. Answer D, the graph approaches positive infinity from the left and from the right. All right, one more. Here's the function. The asymptotes at x equals 4. These answers are in a slightly different form, okay? Since the asymptote is at 4, what this means, right here, this means x approaches 4 from the negative side, okay? 4 from the negative side means it's going to be from the left. So I'll just write LT. And 4 from the positive side, that means it's going to be from the right. All right, just so you understand what that means. So if it's from the negative side, it's from the left. From the positive, it's from the right. And again, they're still using plus infinity or minus infinity. So it's the same thing. All right, so if you need one more, it's the same process. Here we have x equals 4 as the asymptote. All right, I'm going to erase this here. All right, two numbers that multiply to 35 and add to negative 12. For 35, I think you can do negative 7 times negative 5 and get negative 12. All right, so in the numerator, x minus 7, x minus 5. In the denominator, it's x minus 4. All right. For the zeros, nothing to cancel. For the zeros, set this equal to 0. X minus 7 equals 0. We have x equals 7. X minus 5 equals 0. We have x equals 5. Make your number line. All right, we have 7 and 5. 7 is the greatest. 5 is next, and the vertical asymptote is at 4. All right. So this is a 0. This is a 0. And right here is the asymptote, or vertical asymptote. So let's see. It looks like we're going to have to plug in a decimal right here in between the vertical asymptote and the 0. I think the easiest one would be 4.5. Okay, and over here, there's no restriction. So the easiest number for me is just to plug in a 0. All right, so the function is called f. So first we will do f of 4.5. All right, 4.5 minus 7 is negative. 4.5 minus 5 is negative. And 4.5 minus 4 is positive. Negative times negative is positive divided by a positive. How about f of 0? 0 minus 7 is negative. 0 minus 5 is negative. 0 minus 4 is negative. Negative times negative is positive. Divided by negative, that's negative. So right here is negative. And right here is positive. All right. So x. So as x approaches 4, from the right-hand side, so that's 4 positive, the y value approaches positive infinity. And over here, as x approaches 4, from the left or from the negative side, y approaches negative infinity. All right, so from the right it's positive, and from the left it's negative. Okay, from the right-hand side it's positive, and from the left-hand side it's negative.